Good morning to all of you. Welcome, you guys. How we are doing, everybody? कैसे हो सभी लोग? Yeah, we are live. First of all, do check करके बोलिए ना, is the audio videos clear to everybody? Do check करके बोलिए ना, is my audio videos clear to all of you? Do comment करके बोलिए ना here. Is the audio videos clear to all of you? Yeah. Yes. First of all, a great news to all the aspirants who are preparing for GATE 2027-2028 के लिए. Now this Unacademy subscription, you can see this thing just 8,999 only. Unacademy subscription that is just 8,999 only. And इसके साथ आपको extension भी आपको free में मिलेगा. Right. So utilize this code. Be ready and to avail these great opportunities. And this is a limited period offer. So with this, you will have great learning experience from the top educators of Unacademy team. So don't wait, start your serious preparation. We are there to provide you the best knowledge. You can have a look at now here. So this is from 2027 के लिए हमने नया बैच शुरू किया. So digital and then EMFT. So you can find the top educators of Unacademy एक साथ आपको मिलेगा. And these are the Unacademy GATE 2026 rankers. Unacademy GATE 2026 rankers आपको एक साथ मिलेगा. You will have a great learning experience from this top educators team. So ESC 2025 का rankers, ESC 2025 का rankers, right? Start your serious preparation with the Unacademy. We do offer the two subscription. One is plus वाला, the other one is iconic. प्लस में आपको क्या चीज मिलेगा? टॉप एडुकेटर्स क्लासेस, लाइव डाउट्स, एवेल्युएटेड टेस्ट सीरीज, स्ट्रक्चर्ड कोर्सेस, पीडीएफ, लाइव टेस्ट, अनलिमिटेड एक्सेस. आइकॉनिक में पर्सनल कोच भी मिलेगा, फिजिकल नोट्स भी मिलेगा. You can book your time slot according to your time convenience and interact with your mentor. So start your serious preparation with the Unacademy to achieve dream goals. Right. Chalo, let's continue our discussions. Last class, we have seen some problems now. Now we'll continue the remaining problems. This problem completed. 55 तक हमने completed. Next. And take the next problem. To light 50 watts, 100 volts lamp is connected in series with a capacitor of capacitance 50 by pi root 2 with 400 volts and 50 hertz AC. So the value of X is X here, first of all. I think this problem might be some correction is there. We'll see it. Now, as shown in the figure, the steady state, the charge stored in the capacitor is, in steady state, how the capacitor will behave. So tell me first of all. Yes, in steady state, capacitor will behave like a open circuit. Now we can see now equivalent resistance now here. So this is 10, 100 and 200. Okay, so anyway, this is open circuit now, so no effect of it now. 10, 100 parallel. So what is the equivalent resistance? You tell me now here, R equivalent. So this is 10 into 100. 10 into 100 by 110. So this value will give it as 100 by 11. So how much this value of current you can see now? This value 100 by 11. From this we can say this current given by the source. This current, how much this value? This is 10 by, this is 100 by 11. 0, 0 will get cancelled. So that is given as 11 by 10 amperes. This is the current. Okay. Now, mhm. These options are not given. Okay, for this one. Options are not given. Options are wrong. Circuit something issue, I think so here. Where is this R value? Okay, fine. This. Now this is the current now. Anyway, so then this voltage, which is also equal to 10 volts only, isn't it? This is 10 volts. That means Q is equal to what I can say now here, C into V. Q is equal to C into V. So that means Q, we can say this C value, how much now? That is 1.1. And V value, how much now? 10 into 10 power minus 6 now. So how much the charge you tell me now here? This is 11 into 10 power minus 6. This much coulombs now here. So the answer Q value, which is equal to what you tell me now? 11 into 10 power minus 6. Next, a series LCR circuit has inductance, resistance, capacitance. It is connected to AC supply of amplitude is given at frequency at 60% lower than the resonant frequency. The amplitude of the current will be 60% lower than. So first we'll find the resonant frequency. So that means what is the resonant frequency? Tell me now here, omega. That is given as 1 by square root of LC. So this will come to be a what? Tell me now, 1 by square root of LC. Inductance is 10 power minus 2. And C value, how much now here? 10 power minus 6. So this omega value, how much now here? This is 10 power 4. That is radians per second. This is the omega value. Now 60% means what we can say now here? 60 by 100. This is a resonant frequency. They are asking at what frequency? So 60% lower than the resonant frequency. It means what you tell me now here? 10 power 4 minus 60 by 100 into 10 power 4. So then this value, which is equal to 10 power 4 minus, so this is 60 into this is 10Q by 100. So this value will come to be what? Tell me now here, 10 power 4 minus. So this 6 into 10Q. So this value, how much now here? This will be a 4 into 10Q. 4 into 10 cube. Now, at this location, we need the current value. So let us find the impedance now. So this is now Z, which is equal to R plus J into this is omega L minus 1 by omega C. So that is Z, which is equal to R, which is equal to 10 plus J into omega value 4 into 10 cube. L value how much now here? 10 power minus 2 minus 1 by omega value 4 into 10 cube into what we'll get now here? C value how much now? 10 power minus 6. So this Z value will come to be what will be now here? 10 plus J into what we'll get now here? 40 minus this is what we have tell me now 10 cube by 4 now. So how much will come here? So this is 10 plus J into, so this value 10 cube by 4, 40 minus this is 10 cube by 4. This is minus J 210. Right. So at this location, we'll find the magnitude now here. Z is equal to what element now here? 10 minus J 210. Now we can find the mod Z, which will be equal to square root of 10 square plus 210 whole square. 10 square plus 210 whole square. How much is value? This mod Z, which is equal to 210. Now we need to get what tell me now here, current now here. So here AC amplitude is given, the amplitude only they are asking. So this means current I is equal to V by mod Z. How much this value they given? 50 given now. So that is 50 by 210. So this is 5 by 21. How much will come? So this is 238. Yeah, 238 milli. I value which we have 238 milliamperes. Bapre. Big circuit. Yes, this problem correction. This also correction. Na? Now see the 58 one. With that thing, this might be also have correction. I think so. Okay. Correction is here like this. Circuit is like this. No. The effective I in the circuit is the effective I in the given circuit at very high frequency. They asking at very high frequency. At high frequency, what happens? You tell me now here. High frequency. Frequency is very high. So inductor will behave like a open circuit. Capacitor will behave like a short circuit. Now inductor is open. Now this is open. This is shorted. Now this is capacitor is shorted. So this is shorted. This also shorted. And this is shorted. And this is open. This is shorted. And this is shorted. Now you see the flow of current now here. Current will flow like this, will start here, will go like this. Next will go like this. Okay, here we have shorted. Hmm. Now this one, this current they asking. Okay. Next here. So 4 and 1 are parallel. 8 and 2 also. This is okay. This is open now here. Okay, fine. So equivalent circuit, it will come to be what, tell me now here like this. This is shorted here. So capacitor is shorted. Yes, so this is 4 and this is 1 and this is 2. Understood the equivalent circuit now? This is the equivalent circuit now? Okay, this is also 4 only. Oh, this is also 4 only. This is also 4 only. Hmm. This is 220. And this is 220. Now you tell me now, these two now here, fine. So that means how much is value of current? There is no options here. The value of current I is equal to what I will get now here, 220 by 5. Simplify now here. 5 fourths, 5 fourths. How much is I value? 44 amperes. Next one. In a LR circuit, XL equal to R, the power factor of the circuit is P1. Power factor is P1 when the capacitor with a capacitance C, XL equal X input in series, the power factor P2. Yes, I think this problem we did same kind of problem. Initially, they given first LR circuit. In case of a LR circuit, see what they given now here. The impedance, which is equal to what you tell me now, R plus J into XL, and which is equal to R plus J into XL is equal to R only. So what is the power factor now here? that is P by mod Z, that is R by mod Z, that is R by mod Z. So that is given as what we can say now, R by root 2 into R. So the power factor P1, which will be equal to 1 by root 2. Next, now in case of a RLC circuit, now second case, now the capacitor is also added. Then the impedance which will be given as what you tell me now, R plus J into this is XL minus XC basically, where this XC is equal to what you tell me now here, R plus J into this is XL. XC is also equal to XL only now. So the Z will becomes what you tell me now, R. Now what is the power factor now, P2, which will be given as 1. So we can say this as P1 by P2, and which will be given as 1 by root 2. Okay, next one. To increase a resonant frequency in series LCR circuit, what happens now? Source frequency should be increased. Resonant frequency increase करने के लिए what I need to do here? Resonant frequency F naught, which will be equal to 1 by 2 pi into square root of LC. Now we need to add the resistance, should be added in series to the first resistance. I need to increase if I okay and another capacitor should be added in series. If the capacitor is added, that means series connection C1 C2 by C1 plus C2. If the two capacitors are added in series, what happens now here? C1 and this another capacitor which is C2, then equivalent capacitance is what will be now here, C1 C2 by C1 plus C2. That means capacitance value decrease, C value decrease, in frequency will increase now. That means another capacitor should be added in series with the first capacitor. Next, when you walk through metal detector carrying a metal object in your pocket, it raises alarm. This works based upon what? Tell me, this is resonance in AC circuits. Metal detector works on the principle of transmitting an electromagnetic signal and analyze a return signal from the target. So it will works on the principle of resonance in AC circuit. It will works based upon the resonance in AC circuit. Next one. A series LCR circuit with R is given, XL given, connected across 220 volts 50 Hz supply. The value of capacitance needed to maximize average power of the circuit. They ask him to find to maximize, but to maximize this thing here, it should be a resonance condition. It should be a resonance condition. At a resonance, what happens now here? Current is maximum. That means XL equal to XC only. So that means we have now XL value they given, that is 70 by 11 they given. So this will be given as 1 by omega, that is 100 pi into C. So simplify, get the value of C now. How much the C now here? This is 11 11 by 70 into 100 pi. So the C value, how much will come here? 11 by, this is 70 into 100. Pi value, how much now? 22 by 7. So then this value will come to be what I'll now 7 tens, 11 twos. So the C value will come to be what tell me now here? 1 by 2 into 10 cube. Okay. So this value will come micro we need now. So this value we can say 400 now. 400 microfarads. Check it. Hmm. Which one you are asking, Shivakumar? Next. For a series LCR circuit, I versus V shown in figure. Uh, right. Now what the nature you can see now. And this is the resonance case. Now the left side is a capacitive nature. Yes, left side is capacitive nature. Left side is capacitive nature. And the right side is inductive nature. The left side is capacitive nature. Right side is inductive. They are asking which statements are correct. They are asking. To the left of omega, circuit is mainly capacitive. Yes, correct only. Next, so first one is correct only. And left side is inductive. No. At resonant frequency, impedance of the circuit is equal to resistive. Yes, correct. At omega, impedance of the circuit is 0. No. So here, which are the correct now? MSQ. So here, 1 E and C are correct. Next. An inductor of 0.5 millihenry, a capacitor of 200 microfarad, and a resistor 2 ohms are connected in series with 220 volts AC source. If the current is in phase means resonance condition. Current is in phase means resonance condition. In a resonance condition, what they asking to find now here? The frequency of AC source they asking to find. A resonant frequency, that is F naught, which will be equal to 1 by 2 pi into square root of LC. So that is given as 1 by, this is 2 pi into square root of L into C. L value how much now here? So I can say 5 into 10 power minus 4. And C value how much now? 200 into 10 power minus 6. Now simplify and get it. How much will come? F naught value. Yes, so this value will come it as 400. 400 H. So this means it also no options. So this also to be correction. Next one. A telegraph line of length 100 kilometers. Here also no options. This also. Okay. No options actually. This is the numerical. Length 100 kilometer has a capacity of this much. Okay. It carries an alternating current for 0.5 kilocycles per second. That given the frequency given. Okay. If the minimum impedance minimum impedance is required, then the value of inductance that needs to be introduced in series is, okay, minimum impedance is required. Right now here frequency, how much they given now here, that is 0.5 kilo, that means 10 Q. So this means this is 400 cycles per second is nothing but Hz only. Next, capacitance value C is equal to how much now? This is, yeah, 10 power minus 3 microfarads into this value 100 kilometers. 100 into 10 power plus 3. So C value is how much now here? 100 microfarads. And which will be equal to 10 power minus 4. Now we need to get what, tell me now here. So inductance now here F naught. So resonant frequency which is equal to 1 by square root of LC. F naught is how much now? 400, and which will be equal to 1 by, that is square root of L into C. Inductance value we don't know. Capacitance value how much now? 10 power minus 4. So we can say this as 400 into 400. Yes, into 10 power minus 4, which will be equal to 1 by L. Now, so from this, L is equal to what I will get, you tell me now here. 1 by, right, 25. That's it. Okay, pi is also there, now 2 pi is there now, so we should add 2 pi also. That is into 2 pi. So how much this L value will come? And this value 100 millihenry. Okay, next one. An AC source is connected to an inductance of 100 milli, a capacitance of 100 microfarads, and a resistance of 120, shown in figure. Figure is basically here. Okay, so we'll update the figure and we'll see it later. See the next one. In the given circuit, the magnitude of VR and VC are twice that of VL. So that means VR equal to 2VL and VC, which is equal to 2VL. Then the total voltage which will be given as basically VR plus J into VL minus VC. This V is equal to, that is VR plus J into VL minus VC is equal to 2 into VL. So this is given as what element of VR minus J into VL. V is equal to yeah, so what we require basically they asked him to find the value of inductance we should find, right? Now here this is 220, which is equal to, we can say now here VR plus J into VL minus VC is equal to VL. So this is 220, which is equal to VL plus J into minus J. This is minus J into VL. Okay. Yeah, from this we should get what are the inductance we need to get. Mm. Mm. Then what we can say now here, VR, which is equal to into VL, that is I into R, which is equal to into I into omega L. I cancel na, R value given. Yes, directly we can get L value here, that is R by 2 omega. R is what you tell me now, 5 by 2 into omega, which will be equal to 100 pi. This value, how much will get now here? This value 2 and 0. So that is 1 by 40 pi. So this is a K now, so which is equal to 40. Okay, fine. Yes. Okay, fine. That's it for today. And next class will continue remaining problems. Okay, then see you. Bye bye.